Welcome to the Physics Behind the Patriot.
Work equals force times distance. It is the amount of energy done to a system that brings about change. In a roller coaster, work is done when it is pulled up the first hill on the track, and also at the end of the roller coaster to bring the carts to a stop. In the Patriot, we do not know the distance the roller coaster has to reach its peak, but we can estimate it using the conservation of energy. Work equals potential energy, which is equal to 1,331,593 joules. In a roller coaster, energy is added to the system when the roller coaster is pulled to the peak of its track. At that peak, the carts have their highest potential energy in the system, but they have almost no kinetic energy as they are barely moving. As the coaster rolls down the track, potential energy is turned into kinetic energy as the coaster loses height and gains speed. As the coaster goes up and down, twisting and turning, the total energy of the system is constantly being converted from potential energy to kinetic energy and back, but the total energy of the system is conserved except for the slight resistance by friction in the wheels and air resistance. At the end of the ride, work is done negatively on the ride by brakes, taking away energy from the system as the coaster comes to a stop. Potential energy is energy possessed by an object based on its height relative to other heights. The roller coaster gets work added to the system, which is then converted into potential energy when the roller coaster is moved to the very top of the track. For the Patriot, when the cart was moved to the highest point of 91 feet, and when it was at maximum capacity, we estimate that the cart has potential energy of 1,331,593 joules.
Kinetic energy is the energy an object possesses from being in motion. The equation for kinetic energy is 1/2 mass times velocity squared. In a roller coaster, it has no kinetic energy at the top of the track because it is not in motion. However, as the roller coaster runs down the track, potential energy is converted into kinetic energy, which means that at the lowest point is where the roller coaster is the fastest. We calculate that the maximum velocity of the Patriot is 23.316 meters per second. Normal force is the contact force experienced by an object that goes against gravity. In a horizontal setting, normal force equals the weight of an object, which equals mass times gravity. In a non-horizontal setting, normal force equals mass times gravity times sine theta. Friction is the resistance an object experiences by rubbing with another surface. The amount of friction an object experiences equals mu times the normal force, where mu is the coefficient of friction. In the Patriot, the friction in the system comes from the bearings in the wheels. As the wheels spin, there is friction between them and the axle as they are rotating around it. This is a drag force acting opposite to the relative motion of any object moving with respect to the surrounding air. Whenever a roller coaster zooms down the track, there is air resistance slowing down the cart, as energy from the system of the roller coaster is lost by work done on the air. It takes energy for a cart to move the air around it in order to keep moving forward.
Materials used. The Patriot track is mostly made of steel. Steel allows a roller coaster to go at very high speeds and withstand a lot of forces. Steel is a very strong material, though it is more expensive than wood because it is so strong. You don't need to use as much of it. Steel has the strength to keep the roller coaster consistently following the same path without much worry of it breaking, but it also has the flexibility that allows it to withstand extremely high forces without snapping. The motion of the cart. The cart moves in various directions and speeds, so it would be very difficult to calculate the velocity of the cart at any one point. We do know, though, that the highest speed that the cart experiences is 45 miles per hour, or about 20 meters per second. The total runtime of the cart is 2 minutes and 14 seconds, which is 134 seconds, and the total length of the track is 1,920 feet, or 585 meters. Based on this, the average speed of the roller coaster is 4.37 meters per second. The average speed of the cart is much smaller than the maximum speed because the runtime of the roller coaster also accounts for the slow speed the cart gets pulled up on and also when the cart is braking. Forces experienced by the passengers. G-force, which is the force experienced by a person as a result of acceleration with a unit of 1g. The G-force experienced by a passenger on the roller coaster is determined by how fast the roller coaster accelerates. On a roller coaster, the passenger experiences the G-force whenever it accelerates quickly when going down a hill, going through loops and twists, and direction of the motion is changed, or whenever it brakes suddenly at the end of the ride. Centripetal force. Centripetal force is a force that acts on an object moving in a circular path and is directed toward the center of the circle. Centripetal force is commonly confused with centrifugal force, which is the feeling of getting pushed outwards when getting spun in a circle. Centripetal force equals mass times velocity squared divided by the radius of the circle of motion. The force is mv squared divided by r. In the Patriot, the roller coaster experiences centripetal force whenever it goes through one of its two loops or the times the track spins around in a corkscrew.